Hello everyone. Today we will be learning about the metals that react with acids and alkalis. So first we'll look at what these metals are. The aluminium, chromium and zinc. So these are the three metals that react with both acids and alkalis. Now they're called amphoteric substances because they have the ability to react with both acids and alkalis. So they're given the name amphoteric, and it's important to remember this name, amphoteric. When it's reacting with an acid, they produce hydrogen gas as a product, as well as a solution of metal chloride or sulfate salt. So in other words, it also produces a salt, which is usually a metal chloride or a metal sulfate. Now let's look at some complex ions. We have metal aluminium. Now the formula for its complex ion, in other words, its aluminium hydroxide ion, is Al, and you put the brackets on, put your OH, and then you put a 4 next to it. Because we have 4 aluminiums, it's going to have a charge of -1, as you can see. And again, we have chromium, Cr, brackets open, put your OH in, you close your bracket and you put your 4 because there's going to be 4 OH molecules. And then again, it has a charge of 1. So in other words, this is an anion. Zinc, we have the same thing happening. Now this time, zinc has a charge of -2. The complex ion for zinc has a charge of -2. Now the complex ion for aluminium is called the aluminate ion. The complex ion for chromium is called the chromate ion. And for zinc, it's called the zincate ion. You'll have to use these complex ions when you're writing your chemical equations. Let's take one example here. For example, the equation for the reaction of aluminium with sodium hydroxide is. So we'll first look at the reaction. We have aluminium reacting with sodium hydroxide, and they produce water and our sodium aluminate ion and also hydrogen gas. Now to balance this equation, what you first do is put a 2 in front of our NaOH, and this is because we have an excess of hydrogen ions in this side. So to balance our hydrogen ions, we need to put a 2 in front of the NaOH because it has a hydrogen, and we also put a 2 in front of the H2O. Now this is because we have how many hydrogens here? We have 4 plus 2, which is 6. Now we do have 6 hydrogens on this side as well. Note that we have 2 sodiums here, so we have to balance the sodiums. So when you're balancing the sodiums, you need to put a 2 in front of the Na, so it becomes 2Na. But now that means we're going to have 2 aluminiums as well. So to balance our aluminium, you would put a 2 in front of the aluminium. So now you have 2 aluminiums. But then oxygens here aren't balanced. So to balance our oxygens, we have 4 times 2, which is 8 oxygens on this side. To balance the oxygens, what you do is you would put a 6 in front of the O here. We have 2, that gives us 2 plus 6, which is 8. Now our oxygens are balanced. Now we have to finish off by balancing our hydrogens. We have 12 hydrogens plus 2, which gives us 14 hydrogens. Now we already have 2 times 4, which is 8 hydrogens here. So by putting a 3 in front of the H2, we balance our hydrogens. And that's how you would go about balancing your equation for that. Now, when you're writing your ionic equation, what you would do is you would take out the spectator ions. In this case, just look at this equation for the time being. You have sodium here already in a compound, and sodium here is also in a compound, which makes sodium here our spectator ion. Taking out the spectator ions, we just write our ionic equation. We have aluminium reacting with our hydroxide and water, giving us the 2 aluminate ions and also hydrogen gas. The balancing of the equation stays the same. So any balance or any coefficient you wrote here would go into our hydroxide ion, and any coefficient you wrote for this compound here would go into our aluminate ion, as you can see. Now moving on, we'll just summarize the stuff, every information we learned in this topic. So the use of a particular metal are determined not only by the physical properties but also their reactivity. So in this topic, we learn mainly about reactivities of metals. And we also learned how reactivity or its reactivity can benefit its use. So for example, gold is so unreactive and therefore it is used mainly for jewellery. So we have gold and silver and also platinum quite unreactive, and they do not undergo any corrosion, which means that they're very corrosion resistant and very appealing at all times. So they never corrode and therefore always remains or retains its lustre. Because these metals do not readily tarnish, they retain their shiny lustre and make them attractive metals. So this is just summarizing how the reactivity would benefit the use of the metal.